Till then, I'd like to introduce you all with the speaker of the day, Dr. Amandeep Singh Oberoi. Dr. Amandeep Singh Oberoi is an assistant professor in the Department of Mechanical Engineering. He's working in Thapar Institute of Engineering and Technology, Patiala, Punjab. He specialized in the areas of polymer electrolyte membrane fuel cells, unitized regenerative fuel cells, porous mediums for electrochemical edge storage, hybrid energy systems, alternate energy sources, and thermal engineering. He's an active researcher in all these areas, and he's having more than 10 years of experience in industry, teaching, and research. He did his PhD from RMIT University, Melbourne, Australia, in the area of hydrogen fuel cells. He did his PhD in 2016, and since then he's working here as an assistant professor. He's involved in many national and international collaborations and published many of his research findings in international journals and conferences. And he has also guided till now 5 PhD students in the same area of hydrogen fuel cells and more than 5 master students in the same area. So we have with us an active researcher in the field of this hydrogen fuel cells. So I welcome you, sir, on this platform of online FTP, which is on electrical vehicles. I hope all of the participants will gain a lot from Dr. Amandeep Singh Oberoi. I welcome you, sir.
Thank you so much, ma'am. Thanks for the nice introduction. I welcome all the participants in this session of the FTP on electric vehicles. Although coming from the hydrogen engineering background, I'll try my best to put in and relate the EVs with the hybrid EVs. I mean, the fuel cell itself cannot, sustain the entire EV market. And on the other side, the battery powered EVs cannot sustain solely in the EV market. So there has to be a blend between the two technologies in order to bring a sustainable model for the consumers. So I'll put in my best efforts to make your time fruitful, guys. So ma'am, with your permission, shall I start, or are we waiting for some other participants to join in?
Yes, sir, sure, you can start.
Meanwhile, I'll just share my screen so that the participants, they'll be able to, see my details. So in case anyone want to contact me for any further queries or research collaboration, they're more than welcome.
Yes, yes, sir. Thank you.
I hope my screen is visible to all.
Yes, sir.
Great. Thanks for confirming. So for the participants, these are my details which are displayed at your screen. So again, I will not be holding you guys for long, and I don't want it to be a one-way flow. This session is going to be a more of an interactive session. I'll be taking you through many videos, activities, exercises, and for most of you, many things are going to be the new, because the hydrogen fuel cell is yet an upcoming technology as far as India is concerned and the world is concerned.
Sir, I think you can start.
Fair enough, ma'am. Thank you.
Okay, sir.
So those who are joined late, welcome once again, guys, to this session on EVs. And today's session particularly is focused upon hydrogen fuel cell vehicles, an alternate to battery technology. I have been already introduced, but those who are joined late, my full name is displayed on your screens. I am Dr. Amandeep Singh Oberoi, Assistant Professor in Mechanical Engineering Department at the Thapar Institute of Engineering and Technology, Patiala. Now, before I start, let me clarify one thing. Since I graduated from RMIT University, Melbourne, Australia in hydrogen fuel cells, I did my PhD from there. Since then, I'm teaching at this institute. And so far, one PhD student have already graduated under me. He did his PhD in graphene oxides and reduced graphene oxides for electrochemical hydrogen storage. And another PhD is about to pass out. So another 5 PhD students are undergoing. So I'll focus upon today's session. What I'm going to take you through, guys, today is just a sec. Okay, so I'll be starting today's session from SDGs set by the United Nations. SDG are the 17 distinct sustainable development goals which were set by the United Nations for the sustainability. Then I'll be briefing you about the green technology. Most of you, I'm sure, already know what green technology is, but just to brush up your basics, what green technology is and how it is different from sustainable technology. Because today's world, these two words are quite a buzzing words, the green technology and sustainable technology. How these are related to our EVs and the fuel cell vehicles, I'm going to take you through. Then the carbon footprint, again, not a new word for you guys, I'm sure, but for those who don't know about the carbon footprints, here I'm going to tell you what it is. Coming from a hydrogen energy background, we are going to take a deep dive into hydrogen energy and hydrogen fuel cell, why it is considered as the future fuel, how it is produced, and what are the various storage mediums by which the hydrogen can be stored in. Then I'll particularly focus upon hydrogen fuel cell vehicles, HFCVs. Then I'll take you through the research side, because I'm sure most of you must be interested in the research side of the hydrogen. What are the various areas which are undergoing, which are still on the research desk, or which are at the verge of commercialization. So I'll start. This picture, I'm sure you might have seen this before. I'm sure most of the participants have seen it. It's quite a common picture. These are the 17 distinct sustainable development goals set by the United Nations. I'll read quickly for you guys. First one is no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production of energy, climate action, life below water, life on land, peace, justice, and strong institutions. Last one is partnerships for these goals. So we all, coming from energy background, must be interested in the two goals, which is number 7 and number 12, and how these are mapped with today's session and the entire FDP. I'll show you. 7th goal says affordable and clean energy, and then 12th goal says the responsible consumption as well as the responsible production of energy, which leads to today's topic, that is green hydrogen. Okay, now when I say green hydrogen, the word green strikes in the mind. What green actually is? Is it the color of the hydrogen, or what is green? So green, so what green technology basically is, as the picture depicts. So the green technology says that it's an encompassing term. It deals with using science and technology in order to protect the environment. Since most of the nature is referred to as green color, that's why the green technology has been drawn from this term. So green technology means the technology which does not harm the nature yet fulfill your requirements. The green energy means the energy which is developed without causing any harm to the environment. That is green energy. So energy efficiency, recycling, health, safety concerns, renewable sources, and more all go into the making of a green product or green technology. So I hope the basic definition is clear what green technology is, and all the production of any product or services that are being offered to any customer, if it does not involve posing any threat or harm to the environment, that technology or that product or that service is referred to as green technology. Similarly, green hydrogen means the hydrogen production has to be in such a way that no threat or no harm is posed to the environment. Then what is sustainability? If this is green, what is sustainability? Anyone would like to mute and help me out in this? I want to hear from you guys. I don't want it to be a one-way show. What sustainability is?
Sir, the energy which is sustained or which can be redeveloped or reused, that is called sustainability.
Quite close. That's correct, but not 100% correct. Anyone else want to attempt? Come on, guys. Okay, give me the wrong answers. I'm going to give you the right answer for sure. What sustainability is, what it could be according to you. No idea? Okay, I'll proceed without wasting any more time. So concept of sustainability is maintaining the balance between the natural resources and creation of the resources. So far, what mankind is doing, we take the energy as granted. We switch on the switches of our offices, of our home appliances, and we take it as granted that electricity is going to be there and the appliance is going to be running. But if for our energy needs, we are still relying on the fossil-based fuels, let me tell you, the oil reservoirs are only going to last for another 45 or 40 years. Coming back to sustainability, sustainability is maintaining the balance, what we are taking out from this planet, what we are putting in this planet. The consumption of the natural resources and creation of the resources. Most of the people, they are more focused upon consumption of the natural resources, but nobody gives a damn about creating the resources. So sustainability is the ability to be upheld or the quality of being aware and protective of the natural resources and environment during economic and population growth. The ultimate goal of sustainability is to achieve harmony with the environment so that fewer resources are consumed than are being created. But it's the other way around in today's time. More resources are being consumed than they are being created. Okay, but when you create a harmony, when you create a balance, in fact, it should be the other way around. The fewer resources must be consumed than they are being created. So the concept of sustainability all deals with what you can put in this planet and what you're taking out of this planet. And most of us are taking a lot out of this planet, but sorry to say this, we are putting quite less in this planet. And eventually we'll be leaving almost nothing for our future generation to come on this planet. So ask yourself whether all the green technologies which are being showcased or marketed in the market, are they sustainable? Be the solar panels, be your batteries, be your wind energy systems, geothermal power stations, coal power station, definitely they are not sustainable and neither they are green. But all the green technologies which claim themselves as green, are they sustainable? The answer is, well, pretty words are not always true and true words are not always pretty. Not all the green technologies, unfortunately, are sustainable. Okay, so what is to be done? Do you know, is solar PV technology a sustainable solution? I already mentioned it's not, but then give it a thought. What is the carbon footprint of a solar panel? When I say carbon footprint, I mean a carbon footprint is historically defined as the total emissions caused by an individual, event, organization, or product expressed as a carbon dioxide equivalent. In other words, when the solar panel is being manufactured from the different crystals of silicon, the process by which it is manufactured, the process by which it is binded into modules, the process by which it is binded into panels, the machinery, the processes, how much emissions they have caused. That's what carbon footprint is. And to your surprise, the GHG emissions, the greenhouse gas, GHGs are greenhouse gases. The GHG emissions from various processes associated with manufacturing of solar panels, it's huge. It's huge. See, the production of solar cells itself, they tend to 78% of the GHG emissions. Then electrical consumption at the production stage, 13.8, other stages at the product life cycle, 8.2%. So CO2 emissions, the carbon footprint of a solar photovoltaic panel, say there are two types of panel which are commercially available. One is monocrystallines made from a single crystal of silicon. Another one are the polycrystalline made from joining in the different crystals of silicon. So, but the carbon footprint overall of the solar panel is around 72 grams of carbon dioxide equivalent per kilowatt of the energy generated by that panel. So 72 grams of carbon dioxide emission per unit of the electricity produced from the solar panel. Then, since the FDP is on EVs and battery is the heart of EV, let's talk about battery. Is battery a sustainable solution? This is an open question to everyone. Is battery a sustainable solution? It could be a green solution, but not a sustainable, I see. Why? What's a carbon footprint of a lithium battery? Any idea? You can unmute yourself, guys, if you want to take any guesses. If solar PVs have got 72 grams of CO2 emissions per unit of the electricity generated, what would be about the lithium batteries? Lithium-based battery, be it lithium polymer or lithium ion. Any idea, guys? Any idea? Any guesses? Any wild guesses? Am I audible to you all? Participants? Am I audible, guys?
Yes, sir. You're audible, sir.
Okay, thank you for confirming. So I was expecting some participants to speak up. So what do you think, guys, the carbon footprint of a lithium battery? If you're not comfortable in speaking up, you can even type it in the chat box. Equally good. Any guesses? The carbon footprint of a lithium-based battery? How much CO2 equivalent it produces? So let me show you. It is estimated that it produces 1 ton of CO2 per ton of lithium carbonate produced. And lithium, I tell you, is very toxic. And the irony of lithium-based battery is, number one, the lithium-based batteries are too costly to be recycled. In fact, the recycling cost of the lithium-based battery is 5 times than producing a new battery. So no one is interested in setting up or entering into the business of recycling of the lithium. What is happening eventually, we are dumping all the lithium-based batteries when their life cycle is over. We are dumping it somewhere on this planet. And we are converting this planet into a lithium dump eventually. There was a huge, article covered up in Economics Time that Earth being converted into a lithium dump because you cannot recycle it. No one wants to recycle it, not for the sake of environment, because everybody runs for the profits, and there is zero profit. In fact, there is negative profit in recycling the lithium. That's why most of the people, they prefer producing the new batteries than recycling the batteries. Okay, so CO2 emissions are immense. Another problem with the lithium-based batteries are lithium is toxic. It creates a pollution. It affects the flora and fauna. Another problem is the lithium-based batteries when they are fully charged. When they are fully charged, you do not use them for a couple of days. They will discharge by itself. So they are self-discharging batteries. All the batteries, be it lead-acid batteries or lithium-based batteries, because they have got the electrochemical reactions, redox reactions taking place between anode and cathode. If you are not going to use them, the reactions are going to be continuing, and then the batteries will get self-discharge. So what do? Hydrogen might be the solution. Now I'll bring to the hydrogen. Hydrogen, this could be the solution. And that's why it is considered as a future fuel. Why? Any idea? Why most of the economies of the globe, they are setting up their hydrogen economy? And India is also in the line. Why hydrogen is considered as future fuel? Any idea? Any idea, guys? I guess no one wants to open up with me. Anyone can speak up, or you can type it in the chat box. Why hydrogen is considered as future fuel? Okay, I'll give you the answer. See, why hydrogen? Why all the economies across the globe, they're interested in hydrogen? Why it is considered as the next gen solution? You better watch this video for me. I'm going to play this video for you. Okay, just pay attention.
I think we can all agree, the sooner we decrease our reliance on fossil fuels and develop new energy sources, the better. Whether you believe in climate change or not, the benefits extend beyond just the reduction in greenhouse gas emissions, and the supply of oil and gas will inevitably dry. Tesla pioneered our greatest hope in this space to date with the development and popularization of battery technology. But as we've seen, they are struggling to meet the enormous 500,000 pre-order for the Model 3. Elon's self-proclaimed production hell has resulted in delay after delay. Bloomberg estimates that Tesla have produced around 12,000 Tesla Model 3s to date, with the current production rate of 1,000 per week, which will gradually grow to a target output of 5,000 per week. But those at the tail end of the pre-order line could be waiting until 2020 to get their Model 3. This is just the tip of the iceberg. Last year, 72 million passenger cars were built. That's nearly 1.4 million vehicles a week. No matter how successful the internet wants Tesla to become, they will never solve this issue alone, and the industry as a whole likely won't be able to solve it with a battery-only approach. The demand for lithium-ion battery technology is simply growing faster than the supply of lithium can satisfy. So it seems clear, we need a multifaceted approach to solve this problem. Another solution, which was the industry favorite to take over from fossil fuels not so long ago, is hydrogen fuel technology. And companies like Toyota and Shell are working to develop this industry. It won't be an easy race, but hydrogen may well prove to be the tortoise that beats the hare. Hydrogen has 3 primary obstacles it needs to overcome to become a viable energy source for any industry: safety, infrastructure, and cost. Let's get the big elephant in the room out of the way first. I know it's on your mind. If hydrogen fuel cells are ever going to make it to public roads at scale, the hydrogen needs not only to be safe, but to be perceived as safe. And yes, filling a gigantic, incredibly flammable balloon with hydrogen is a pretty bad idea. Hydrogen has a relatively low ignition temperature and a very wide ignition range for air-to-fuel mixture percentages. The fact it's pressurized makes explosions a worry, but it has one massive advantage over oil-derived fuels. It's lighter than air. It can be purged using emergency valves in the event of a fire, and if it does ignite, it won't pool around the vehicle, engulfing it and its passengers in flames. Toyota even tested their carbon fiber tank by shooting it with a 50 caliber round. The tank didn't explode, it simply let the lighter than air gas to escape and vent to atmosphere. Hydrogen is arguably safer than gasoline. So safety isn't a huge concern for hydrogen, but the lack of infrastructure is. Battery-operated vehicles have had a huge head start in this space. The electric grid is a pre-built transportation and generation network for the fuel that battery-operated vehicles require, and installing a charger in your driveway or garage isn't a huge challenge. Hydrogen doesn't have such luxuries to kickstart the hydrogen economy. There are few large-scale production facilities in the world, with the largest being Shell's Rhineland oil refinement facility. It uses its own hydrogen production in the oil refinement process, but the lessons learned from these efforts have allowed Shell and its partner ITM to make hydrogen a viable option for uses in energy storage. Last month I was invited to London to witness the opening of the UK's first ever hydrogen fuel pump to be included under a fuel station canopy, a pivotal step in making the public see hydrogen as an integral part of the transport ecosystem. What fascinated me about this site was how the hydrogen got there. Transporting hydrogen in pressurized trucks would be too expensive as there are no large-scale production facilities nearby. And although hydrogen can be transported within the already established natural gas pipelines around the world, for use in vehicles we need pure hydrogen. So Shell and ITM took the next logical step to keep costs down. They built a hydrogen production and storage facility on site. The production facility is placed just behind the main station and is capable of producing 80 kilograms of hydrogen a day. The Toyota Mirai on site had a range of 480 kilometers with a full 5 kilogram tank of hydrogen, vastly more than a full charge for a Tesla, but you must consider the huge upfront costs of batteries, which do not last forever in this equation for cost. I'll explore this battery versus hydrogen dilemma more in a future video, but for now, let's see how hydrogen actually works. The production process of hydrogen is pretty simple. It uses a process called electrolysis to separate water into hydrogen and oxygen. The electrolyzer consists of two metal-coated electrodes and a DC power source, which provides a negative and positive charge. Hydrogen will appear at the cathode, the negative electrode, where electrons react with the water to form hydrogen and hydroxide ions. These negative ions now present in the water are attracted to the anode or positive electrode, where they are oxidized to form oxygen and water. The rate of production of oxygen and hydrogen depend on the electric current, but pure water is not very conductive. To achieve adequate hydrogen production, we would need to increase the voltage or increase the conductivity. It's much more efficient to increase conductivity, so an electrolyte in the form of salt is often included as a charge carrier. This is the oldest and most well-established production method for hydrogen. For reasons I won't go into, but will include reading materials in the description, this method isn't suitable for quick response times with slow startup procedures and safety concerns, making it completely unsuitable for variable renewable energy sources, which has historically made hydrogen prohibitively expensive. If hydrogen has any hope of becoming a popular fuel source, we first need to get its price down to be competitive with batteries and fossil fuels. This has been a major point of research for the past 50 years, and PEM, or proton exchange membranes, are the primary solution now coming to market that are facilitating a realistic hydrogen economy. PEM replaces the electrolyte-rich water for a solid polymer electrolyte membrane sandwiched between the anode and cathode, with channels to allow water and gas in solution to flow through. As its name suggests, the PEM only allows protons to pass through it, so hydrogen ions, otherwise known as protons, now become the charge carriers rather than the hydroxide ions. But the overall chemical reaction is exactly the same, while requiring less voltage to operate efficiently and, more importantly, has a rapid response time, making it ideal for integration to the grid as an energy storage method. And this is where it truly drives down costs. The hydrogen fuel cells in cars use this exact process in reverse to power their electric motors. The cost of hydrogen production by electrolysis is completely dependent on electricity prices. If an electrolyzer cannot take advantage of cheaper intermittent surge electricity or use cheaper off-peak electricity, then it's losing out on real cost savings and can't provide the valuable service of energy storage for the grid. This hydrogen facility at the Shell station can form an important part of the renewable grid infrastructure going forward. Hydrogen's greatest chance at success is by fueling a new economy of hydrogen, where natural gas pipelines are supplemented with hydrogen produced with cheap renewable energy, allowing hydrogen to gradually grow to be the Earth's primary energy storage method and facilitating renewable energy to become a larger part of our energy grid without the worry of weather impacting energy supply, allowing nations to stop depending on the importation of fossil fuels and instead grow their own fuel economy. One tiny group of isolated islands in the bay of my home county of Galway is attempting to do just this. The Aran Islands are rural Irish-speaking islands popular with tourists for their unique landscape, but have historically depended completely on the mainland for fuel. There are no trees here, no coal, no turf, no oil. But what they do have in plentiful supply is wave and wind energy. They are the perfect candidates to develop a mini hydrogen economy, an economy where they generate their own renewable energy and create their own fuel to heat their homes and power their vehicles. Who knows, these tiny obscure Irish islands could be the birthplace of the world's first self-sustained, renewable, zero-carbon hydrogen economy. Thank you to Shell for sponsoring this video and inviting me out to London to film on location. If you'd like to learn more about the future of transport systems, Shell hosted a live recording of the Intelligence Squared podcast in London, which you can listen to with the link in the description. As always, thanks for watching, and you may have noticed we crossed a...
Okay, so I hope this video was a bit of interesting for you guys. See, now, why hydrogen? Again, the question retains. See, most of the renewable sources of energy that are available on this planet, they are inherently variable in nature. Sun, for example, is not available 24/7. Wind is not available 24/7. Moreover, the energy produced by all the renewables has to be stored somewhere in order to supply or to meet the continuous power demand. So what to do? If we are still going to rely for storage on the batteries, and if the energy stored in the batteries are not consumed on time, they are self-discharging batteries. The energy is going to go in vain. Whereas hydrogen is emerging as a potential candidate, not just for fueling your cars, but also as an energy carrier. Hydrogen on planet is not available as free form. You will not see the product of hydrogen, but they are available. The hydrogen is available in the complex chemical compounds of carbohydrates, be it wood, be it coal, petrol, natural gas, reversible hydrocarbons. So hydrogen is bonded with either carbon or oxygen on this planet. Okay, I hope you all agree on this. Now, the bond energy, the CH bond, the bond energy between intermolecular forces between carbon and hydrogen. In petrol, it's around 400 kilojoule per mole. So in order to break this bond, you need to supply more than 400 kilojoules of energy per mole of the hydrogen or per mole of the petrol. For natural gas, it's almost the same, but for reversible hydrocarbons, you see NCMH, the bond energy is quite weak. It's quite low. So it's only 30 to 50 kilojoules per mole needed. But on the other side, if you see the extreme right-hand side column, the heating value, if you burn a wood, a kg of wood will liberate 22 megajoules of energy. If you burn a coal, a kg of coal would liberate 33 megajoules. If you fire petrol, as we does the gasoline in our cars, it liberates 43 megajoules per liter or per kg. Natural gas 54, diesel is around that 49. But have a look on hydrogen. Hydrogen in its purest form, if burnt, even a liter of hydrogen or kg of hydrogen would give off 142 megajoules. It's almost 3 times that of the petrol or that of the gasoline. So the reason why most of the countries, most of the economies across the globe, they are interested in hydrogen is because of its immense energy content. It's 3 times than the gasoline. And let me tell you, the gasoline, which are the complex compounds of carbohydrates, petrol, C8H18, the powering source is only the hydrogen. Carbon is something which get deposited in the inside of the inlines of the IC engines, internal combustion engines, which need to be get rid of. That's why we go for the servicing. We clean the deposited carbon. The only powering source is hydrogen. The only problem with hydrogen is we are not able to fire it controllably. Its combustion is not controlled. It's spontaneous. That's why the hydrogen is blended with either the ethanols or the biodiesels to get better GCVs, gross calorific values. But if we are able to fire it in the IC engines, it's the cleanest fuel. Let me tell you, it does not emit any greenhouse gas. It's the cleanest fuel ever known to the mankind. Its emissions are 0 and the energy content is immense. Now, not only as a fuel, it is also considered as an energy carrier. That's why most of the countries are working on the research side for this development of the safe and efficient storage system of the hydrogen. How it can be produced? renewably or green hydrogen, how it can be produced? Let me tell you. Have a look on this video, please.
Photovoltaic panels are an ever-advancing technology used throughout the world which creates electricity from the sun. However, storing the electricity for later use is the biggest challenge facing users of this technology. When not feeding into the grid, people have had to rely solely on batteries for energy storage, which are expensive, difficult to dispose of in a safe manner, and have to be replaced frequently. But now there are other viable technologies and systems for storing energy, even for the average homeowner. The system we want to introduce to you is hydrogen energy storage. Hydrogen energy storage has several important advantages over battery systems. The underlying technology that makes this possible is hydrogen electrolysis. You may remember your high school chemistry teacher using low voltages to create reactions in various solutions. This is the electrolytic process and can be used to split water into hydrogen and oxygen. The machine that does this is a hydrogen electrolyzer. We use hydrogen electrolysis to convert electrical energy and store it into tanks in the form of hydrogen, which can be transformed later back into electricity. Hydrogen electrolysis from water is usually undertaken with liquid alkaline or polymer electrolyte membrane electrolyzers. The alkaline electrolyzer works by immersing two electrodes in a liquid electrolyte. When a voltage is applied, the product gases are released, in this case oxygen and hydrogen. However, it does pose some problems. It is unable to make efficient use of intermittent power supplies, meaning it's incompatible with renewables. It also compromises efficiency during storage. To store enough hydrogen for regular use, you would need either a giant tank or an additional compressor. The PEM electrolyzer overcomes some of these issues by using a solid polymer electrolyte, which is the membrane responsible for the conduction of protons, the separation of hydrogen and oxygen, and the electrical insulation of the electrodes. It's able to make use of the fluctuating power supply from renewables and results in pure hydrogen due to the solid structure of the electrolyte. It is easy and more efficient. However, it has a prohibitively high cost due to its required use of gold, iridium, and platinum. Fortunately, a new type of electrolyzer, the anion exchange membrane or AEM electrolyzer, provides a solution to all of these problems. It uses an alkaline solid polymeric membrane, eliminating the need for rare and expensive noble metal catalysts. The AEM electrolyzer is a simpler and more efficient system that produces directly compressed hydrogen. It's the key technology that enables lower overall costs. The AEM electrolyzer combines the benefits of the PEM electrolyzer with the cost of an alkaline system. It's an important breakthrough which will enable the economical adoption of hydrogen energy storage systems all over the world. Please contact us for more information on this groundbreaking technology and how it can.
I hope this video gave you the fair bit of idea how hydrogen can be used for energy storage, how it can be used as an energy carrier. Digvijay, I know you are typing in a chat box. I'll take up the queries later in the later session. You can take a note of your queries, and then after my presentation, I'll be more than happy to answer your individual queries. All right, guys. So now, you know that hydrogen, they can be used, it can be used in the fuel cells, it can be used in the IC engines directly, it can be used for storing the energy. Imagine a renewable energy source, be it a windmill or a PV. instead of storing the produced electricity in a battery, they are using that electricity to generate hydrogen, and that storing the electricity in the form of charged hydrogen or hydrogen charge. And later on, when the renewable source is not available, the stored hydrogen can be pumped back into the fuel cell to generate electricity. I'll give you the idea how the fuel cell works. It works opposite to the electrolyzer, the PEM electrolyzer, which you have seen. So PEM is my key area where I work in. Now, what used to happen, the conventional green hydrogen production and storage system, how it used to function. The hydrogen can be stored as gas, okay, but for storage, you need to be pumping in the gas into the cylinders, and to pump in to get the increased gravimetric energy storage densities, you need to raise the pressure close to 350 to 700 bars. That is challenging because you need to be spending a lot of energy to create those pressures. Or it can be stored as liquid, but for liquid, the hydrogen to sustain in liquid state, cryogenic temperatures are required, that is close to or even lower than 20.28 Kelvin. Again, you need to spend a hell of energy in compressing the refrigerants and then rotating that refrigerants across the hydrogen gas to convert it into liquid and to maintain those temperatures. So both the cases, the energy expenditure is required. If you want to store the hydrogen as a compressed gas, or you want to store the hydrogen as a liquid hydrogen. So energy expenditure is required. The only safest possible way of storing the hydrogen is the third one, which is the solid state of hydrogen storage or electrochemical hydrogen storage. That is storing the hydrogen as a chemical compound by bonding it with some another compound. Okay, so these are the three distinct ways how the hydrogen can be stored: as a gas, as a liquid, as electrochemical. So I primarily work on the third one, which is the safest form of storage, electrochemical hydrogen storage or solid state hydrogen storage. Okay, now, did I miss something? No. Okay. Now, the PEM, which you have seen in the video, the PEM stands for polymer electrolyte membrane, or it's also called proton exchange membrane. Why the name proton is given? Because it only allows the hydrogen protons to pass through it, but does not conduct electrons at all. So it was also shown in the video that this is the conventional green hydrogen, PEM-based green hydrogen storage system from renewables. Now just have a look on this picture. The sun's energy through photovoltaics is converted into a DC power. A DC power is used to run a PEM electrolyzer. We feed in the water into the PEM electrolyzer. PEM electrolyzer consists of a central membrane, which is the central part of the entire electrolyzer. It acts as a barrier for the electrons. So on the left side, which is where we supply the water, under the presence of under the presence of catalyst, primarily the iridium oxide and platinum, the H2O is disassociated into H2 and O2. O2 is directly allowed to move out of the cell and is collected, is compressed and collected in the cylinders. Okay, and H2 is further disassociated in the presence of platinum into H plus and E minus ions. The H plus, being the protons, are allowed to move to the right side, which is the cathode side of the electrolyzer through the membrane. It's a proton conductor, and hence the name proton exchange membrane. So H plus moves to the cathode side through the membrane, and E minus are left with no other way but to travel through the wires, through the external electrical circuit. And on the right side, on the cathode side, H plus and E minus, they combine to give you the H2 again. Okay, which is compressed and collected in the cylinder. This is how a PEM electrolyzer works. So the stored H2 and O2, they can be fed back into the PEM fuel cell when sun's energy is not available. The PEM fuel cell does the opposite. It breaks the supplied H2 and O2 again into H plus and E minus ions. E minus travel through the electrical circuit, hence meeting your electricity demand. And then E minus, H plus and O2, they again merge back to H2O. That is how the fuel cell works. This is the PEM-based green hydrogen production and storage system. But the question is, can H2 power your cars? The answer is yes. Either the H2 can be fired in your conventional or current IC engines, not as a pure gas, but by blending it with the biodiesels or ethanols, or H2 can directly be used. Your IC engines of the car can directly be replaced by the fuel cell, and the stored H2 can be used to power your fuel cell. The fuel cell can run on the stored hydrogen and the air, the oxygen which is present in the air. You just need to fill up your tank as you does for the CNG. Like you fill up your CNG tanks of the car, the compressed natural gas. Similarly, you need to fill up the H2 tanks of your car. And then the H2 can be supplied to the fuel cell. The fuel cell, this is the one reactant. Another reactant can be the air or the oxygen. So the H2 and O2 is available for the fuel cell to develop the power. Now, to maintain the continuous supply of the power, you definitely need the battery again. But addition of the fuel cell can give you the additional long range, which EV alone cannot provide. Let's have a look on the video.
Fuel cells have the power to change our world. At Ballard, we are dedicated to making fuel cell technology a reality, to replace the internal combustion engine in your car with a clean, quiet, pollution-free fuel cell engine. Fuel cell-powered cars look just like other cars on the road today, but they are cleaner, quieter, more efficient, and work very differently. When you turn the key, hydrogen and compressed air flow to the fuel cell module, which contains the fuel cell stack. A fuel cell engine consists of the proton exchange membrane, or PEM, fuel cell module, coupled with the systems required in a typical automotive engine. The electricity produced by the fuel cell is delivered to the electric drive system in the vehicle. The drive system converts electrical power into the mechanical energy that drives the wheels of the car. The fuel cell generates electricity that can be used to power a car, truck, bus, or other vehicle for as long as fuel is supplied. The fuel cell is 2 to 3 times more efficient than your gasoline engine and does not create pollution. Additional benefits include increased performance and onboard power, higher reliability, and greater flexibility in vehicle design and engine layout. But how does the fuel cell work? A single PEM fuel cell is made up of 2 plates, 2 electrodes, and 2 thin layers of platinum-based catalyst, separated by a plastic membrane, which, when fed with the fuel, reacts electrochemically to create electricity. Hydrogen from an onboard storage tank and oxygen from air are fed through channels on the plates. Hydrogen flows on one side of the membrane, air on the other. The catalyst splits the hydrogen molecule into protons and electrons. The protons can pass through the membrane. The electrons cannot, and have to pass through an external circuit, creating useful electricity. On the oxygen side of the membrane, the protons and the electrons react with oxygen from the air in the presence of a second catalyst layer, generating water and heat. By stacking together single cells, like slices in a loaf of bread, you make a fuel cell stack to produce the required amount of power. Just like your car, fuel cells need fuel to operate. The Ballard fuel cell uses hydrogen as a fuel, which can be produced in many different ways, and once produced can be stored as a compressed gas or liquid, or in a chemical or metal compound. Different areas of the world will create hydrogen in different ways, depending on economics and available resources. Hydrogen can be delivered to fueling stations by road, barge, rail, or pipeline, or can be made on-site at gas stations. People may one day be able to produce their own hydrogen at home. You can see there are many options available to enable the hydrogen infrastructure to grow. Fueling the vehicle is very similar to the way you refuel your vehicle today, but requires a special sealed connection before the hydrogen can be pumped into the vehicle's storage tanks. It only takes a few minutes to refuel a fuel cell car. And when fueled by hydrogen, a fuel cell emits water and heat and no pollution. Think what this means to the air around us. Now that you understand how the technology works in a fuel cell vehicle, you can look for them on our roads and ask yourself whether the vehicle you see is powered by Ballard.
So now I guess the things are clear how the compressed hydrogen can be used in the fuel cell to power your car. the good thing is the emission is absolutely zero. No greenhouse gas emitted at all from any fuel cell powered vehicle. Okay, and the range which you get is immense. Only the 5 kg of the stored hydrogen in a compressed form would able to give you 480 kilometers of the range. 5 kg of hydrogen and 480 kilometers of the range. That is what it is coming up in the hydrogen, in the Mirai. So the hydrogen fuel cell cars that are commercially available in the global market, one is by the Toyota Mirai, MIRAI. Another one is by Honda FCX Clarity. The name Clarity is given due to obvious reasons. No emissions at all. The clear emissions are there, only the heat and the water. That is what is emitted. And water is not that too much in quantity. Only a 1 drop or 2 drops of water for a kilometer of a drive. That's it. And there is another one, Mercedes Benz, that's a fuel cell powered car, which are available. Beside the cars, there are commercial trucks which are powered by fuel cells nowadays in Europe. And in Indian scenario, that's the Mirai. So video that we just saw was the second generation Mirai by Toyota. It provides you the range of 700 kilometers by a single full tank of the compressed hydrogen gas. Now, H2 fuel cell vehicles in Indian market, Hyundai Nexo is the first commercial fuel cell powered car that is going to be launched by Hyundai. It was expected to be launched in 2020, but due to pandemic, it got delayed. So now they are planning to launch it either in 2022 or later in 2022, somewhere in November or December. Tata Motors have already launched their bus powered by fuel cell. Okay, they are using the 1.5 kilowatt fuel cell stack. It consists of around 35 single cells combined together in series to form a stack. So in India, of course, the biggest hurdle is the hydrogen infrastructure. Not only in India, but across the globe, we need to set up the dedicated infrastructure or the hydrogen filling station or refilling station. So we need to make a dedicated corridors for hydrogen fuel cell vehicles to motivate the people to go switch on to the hydrogen fuel cell vehicles. Let me tell you again, hydrogen fuel cell vehicle does not come alone or solely with the fuel cell. It does come with the lithium-based batteries to store the charge and to supply the continuous power to the drive motors, because there could be fluctuations in the power generation as far as the fuel cell power generation is concerned. It will depend upon the flow rates of the reactant, that is the air and the stored hydrogen. The flow rate of the stored hydrogen can be controlled, but for the air, you need to store it first and then supply it in a continuous form. Okay, so to overcome this power generation fluctuations, the fuel cell is coupled with the battery in the fuel cell vehicle and to provide the additional range as well. So we can set up a dedicated corridors for the hydrogen fuel cell vehicles to motivate the consumers to switch on to HFCs. Then we need to set up H2 refueling station. Of course, in India, the cheapest or the viable way of generation of hydrogen would be setting up the own domestic power generation house at the fuel cell refueling stations. On-site H2 generation and compression facility has to be developed, and user benefit policy need to be developed to benefit the user. Government subsidies, of course, will attract more consumer to switch on the fuel cell vehicles because they are the emission-free vehicles. The pollution can drastically be reduced if the entire transportation can be switched on to the fuel cell powered vehicles. Let's see, I'm talking repeatedly about the refilling station, how they work, how they produce the hydrogen on site, of course, by electrolysis, and how they maintain or how they store the H2 in the compressed form. To store the H2 in a compressed form, the pressures of 350 to 700 bars are required. A small last video for you guys.
Hydrogen vehicle drivers have a lot to smile about. Instead of exhaust fumes, the only emission is water vapor, and that's pretty much the only change for the driver, including the way you fill up. Fuel costs comparable to gasoline. Range similar to a combustion engine. Fueling process still with a classic fuel pump. Time needed for fueling just like before. The hydrogen filling station itself is a high-tech facility, starting with the storage. The gas awaits customers in racks of cylinders or an above-ground fuel storage tank. Hydrogen is very amenable to compression, so there's space here to fully fuel around 60 vehicles. In order to get a similar amount of energy into a hydrogen vehicle as with gasoline or diesel, the fueling process requires much higher pressure than is needed for storage. This is why hydrogen filling stations have compressors to reduce the volume of the hydrogen by an additional 94%. The highly compressed fuel undergoes minimal expansion during the fueling process at the pump. And when hydrogen expands, it warms up. To ensure that temperatures don't rise too much when refueling, the hydrogen is cooled to minus 40 degrees Celsius before it reaches the nozzle. The fueling process is monitored electronically. If all of the measurements are normal, a full tank takes around 3 minutes. 700 bar pressure in the tank means the end of the process. The hydrogen then has an effective volume of 55 cubic meters, equivalent to around 250 full bathtubs. There's loads of energy contained here, and yet a hydrogen tank is no more dangerous than a battery or a gasoline tank. If a fault is detected, the fuel is released in a controlled manner. If the highly resilient container is damaged, then the fuel dissipates immediately. Hydrogen is 13 times lighter than air, therefore it rises rapidly and mixes with the air where it is completely harmless.
So this shows how safe the usage of the hydrogen gas is. Okay, because there is a myth about the hydrogen gas that as the hydrogen is used in the atomic bombs or hydrogen bombs, it is very dangerous to be used. The firing of hydrogen, I repeat, is still uncontrollable. It's very spontaneous. It cannot be controlled, but using the hydrogen as an energy carrier is the best way ever discovered for using the hydrogen in the transportation applications. Okay, and the videos here itself proves that how beautifully the hydrogen is capable of powering your vehicles, and not only powering, but it's harmless to the environment as well. Talking about the infrastructure in Norway, there is a HyNor project which is building up of the dedicated hydrogen-based highway between Oslo and Stavanger in Norway. Okay, it consists of setting up of the hydrogen refueling station. The HyNor project is a nationally supported project to facilitate and coordinate the introduction of hydrogen as a fuel in Norway. It was between 2003 to 2012. Now, towards the commercial introduction of hydrogen vehicles in 2015, this HyNor project was initiated. The HyNor project focused on the acquiring an early pre-commercial fleet of hydrogen vehicles and keeping a close dialogue with the leading car manufacturers around the world. This is how Norway has stepped forward or come forward to accept hydrogen as a fuel in their country. Similar thing needs to be done in our country as well. Now, the interesting part, what is going on the research side pertaining to hydrogen? Okay, if you remember, it's a similar picture which I've shown you in the production of the green hydrogen. Now there, if you see, if I can take you back very quickly to that picture, you'll be able to relate this one. The crux of the story is you see here a separate electrolyzer to disassociate water using the sun's energy and then storing it separately into oxygen and hydrogen and using it back into a separate fuel cell to generate electricity. Okay, but then on the research side, the researchers have merged separate electrolyzer and separate fuel cell into a single unit just to increase the overall efficiency of the system. That single unit is termed as unitized regenerative fuel cell. This is what it is. If you see the central part. Now this URFC or unitized means combination, uniting electrolyzer and fuel cell into a single unit. Regenerative means it's reversible. It can regenerate electricity. It can regenerate water, and it acts as a fuel cell as well. So single unit running both as electrolyzer and fuel cell. In one go, it acts as electrolyzer. It splits water into hydrogen and oxygen. Similar way, the hydrogen and oxygen produced are compressed and stored into the cylinders. And when the polarities of the cells are reversed, that is when cathode and anode are reversed with each other, they are swapped with each other. This single cell acts as a fuel cell, in which now you need to supply back the stored oxygen and hydrogen to give out the electricity. So the two separate units, separate electrolyzer and separate fuel cell, is now being transformed into a single unit, which is called URFC. Another thing, then future evolution termed up into a proton battery. This is really interesting. This is my research work. Now the concept of proton battery, this originated in RMIT University, Melbourne, Royal Melbourne Institute of Technology in somewhere around 2014, wherein even the storages was clubbed together in a single unit. Here you see the URFC still is relying on the compressed oxygen and compressed hydrogen gas. But over here, even a single integrated hydrogen storage element is introduced within the cell, So there is absolutely no need of separate compressors and separate cylinders to store the produced hydrogen and produced oxygen. Okay, the single unit will act as the electrolyzer and fuel cell. Also, the generated hydrogen will be stored electrochemically within this hydrogen storage electrode. Is there any doubt, guys, so far? I mean, something is disturbing, creating a disturbance. Okay, I'll proceed. Now, the active research is going on different hydrogen storage materials. In this, the hydrogen is stored electrochemically by physisorption and chemisorption. That means the hydrogen ions, the H plus ions, instead of transforming into H2, they are adsorbed within the porous electrode. Either they are physically withheld under the influence of the van der Waals forces, or they form a weak chemical bonds on the internal surface of the pores of the electrode. So then came the concept of carbon HPAC. That means consider the storage as the multi-story car parking. Consider this car parking as the porous electrode and consider the cars as H plus ions. So just imagine the H plus ions which are being produced and emerge at the proton exchange membrane. They are moving into the storage. They are getting parked as the cars, and when required in a fuel cell mode, they are getting out, that is discharging of the battery. Since the charging and discharging is taking place in terms of hydrogen protons only, the name has been given as a proton battery. Okay, this is what carbon HPAC concept is. The parking area is referred to as the porous carbon material, which has got intense pores, all range of macro pores, mesopores, micropores, ultra micropores, depending on the size. And cars are referred to as H plus ions, which get adsorbed either physically or chemically within that carbon. Why carbon? For H storage, carbon usually is considered as poor catalyst for H2 gas formation. We do not want H2 gas to be formed when H is being produced at the membrane. Carbon is available easily. It's available abundant. It's in abundant. It's lightweight. Okay, its atomic mass is only 12 compared to, say, various metals like nickel 59, cobalt 59, so on and so forth. So these are used in complex metal hydride materials, AB5s. Porous carbon media has got very high surface areas, okay, and they are inexpensive, at least for the precursors. Now, as I mentioned, this concept got originated in 2014 at RMIT University, there where the testing was done on the complex AB5 metal hydride for storage of the hydrogen. Okay, then unfortunately, the testing of the fuel cell, no detectable signs of hydrogen was found. The reason being, the polymer which is being used as a membrane is NAFION, NAFION, NAFION 117, which is the perfluorosulfonic acid. That's a chemical name. It's a membrane. Its molecular size was too big, and hydrogen produced did not penetrate in the metal hydride, and if it did penetrate it does not came out because it formed the strong bond. Because metals, they usually allow the hydrogen gas to form instead of hydrogen adsorption. I'll proceed further. A schematic of the various pores depending upon the pore size that are available in the carbon. Macropores having the pore size more than 50 nanometer. Mesopores having the pore size diameter ranging from 2 to 50 nanometer. Micropores are 0.7 to 2 nanometers, and ultra micropores are less than 0.7 nanometers. Now, these ultra micropores are considered as active sites for solid state hydrogen storage in the form of physisorption due to the weak van der Waals forces. Proton battery looks like similar to a PEM fuel cell or a PEM electrolyzer. It consists of the two end plates. These are called the bipolar end plates. It consists of the flow channel which are carved on the end plates. It allows the reactants to distribute on the active area quite evenly. Then comes the silicon gasket to avoid the leakage. Then the GDL. GDL is gas diffusion layer through which the gas is diffused into the active area. Then the catalyst layer, separate for the oxygen side. Usually iridium, ruthenium oxides are used on the oxygen side to split water into oxygen and hydrogen. And platinum black is used for the hydrogen reduction reactions, HRR, to reduce H2 into H plus and E minus. And H plus is the transport media within this proton battery. It has got a naphthalene membrane in the center. Naphthalene, the chemical name is perfluorosulfonic acid. It's a proton exchange membrane. It only allows the protons of H plus hydrogen to move to and fro, but does not allow electrons to pass through it. Then comes the storage material made up of generally any carbon precursor, be it activated carbon, be it graphene, be it CNT, carbon nanotube, carbon nitrides. We are testing many materials. This is what is going on the research side. Then the carbon-based GDL, and then the another hydrogen side end plate. Now on the research side, we guys are working upon the different design of the flow field made by these flow channels. There are parallel design, serpentine design. One of my PhD student is working on the various different design of the flow fields. Parallel serpentine, interdigitated, pin type design. Many designs are there. Then one of my PhD student is working upon exploring different materials for hydrogen adsorption. We have tested so far the reduced graphene oxide, normal graphene oxide. Then we have tested activated carbons made from charcoal. We have tested the single wall carbon nanotube, multi-wall carbon nanotube, and one of my PhD student is now working on carbon nitride, decorated carbon nitride for electrochemical storage of hydrogen. Another thing is one of my student is working on the catalyst layer loading. See, the catalyst which is being used either in the commercial fuel cells or is these research fuel cells like proton battery. There are some rare earth metals like platinum, iridium, ruthenium oxides, which make the entire fuel cell very costly. So the aim is to reduce the catalyst loading. Catalyst loading density is the catalyst being loaded in milligrams per centimeter square of the area. So we are trying to optimize this catalyst loading so that the production cost can be reduced. Also, we are looking for some alternate catalysts like magnesium-based catalysts so that we can get rid of platinum to reduce the cost. This is the actual picture of the fabrication of the proton membrane. What you see in front of your screen is a MEA, membrane electrode assembly. It is made up of the naphthalene membrane, which is the transparent polymer cover which you see all around. And if you can read through, in the orange color on the right side, top side, it's written 2 milligram of platinum black plus 2 milligram of iridium ruthenium oxide. Okay, and the active area is 25 mm by 25 mm. So catalyst loading on both the side plus the membrane in the center makes it the MEA, that is membrane electrode assembly. This is the central portion of the proton battery or the PEM, reversible PEM fuel cell. This is the actual photograph of the stainless steel SS316 carved end plates of the proton battery or the reversible fuel cell. You can see the flow channels being cut. These are the parallel flow channels. There is a depression in this plate to accommodate the activated carbon or carbon-based electrode, which is used as storage for hydrogen. Okay, and this is sandwiched together, and this is the assembled form of proton battery. So the future vision for energy storage is coal for storing the energy rather than coal or carbon rather than energy from the burning coal. Okay, now I'm almost done with my presentation, guys. Before we close up, I'm happy to take up the queries. Ruchika ma'am, are you there?
Hello, sir.
Yeah, go ahead, please.
Sir, my name is Padmavati.
Hi, Padmavati.
Hello.
Yep, you are audible.
Yes,
go ahead.
Yeah, sir, what is the difference between carbon and activated carbon?
A huge difference. Let me tell you, the major difference is between the surface area of the internal pores. like the charcoal which is available, you burn the wood, you get the charcoal. Okay, you grind up the charcoal, you get it tested in under the microscope, and you see what is the surface area of the pores which are available in that charcoal, because that's a pure carbon, that's not activated. Until unless you activate it physically or chemically, what happens, it opens up, its pores open up, and the surface area increases drastically. For example, the carbon surface area is close to 1800 and let me check, I'm not sure. Yep, it's somewhere around 1800. And if you activate the same charcoal, the same carbon, either chemically or physically, the surface area can goes up to 3000.
Okay.
Okay, so major differences between the surface area, and particularly for hydrogen storage, more the surface area, more are the active sites available for the hydrogen storage for making the chemical bond at the internal surface of the pores. If I can show you this diagram, just this one. See, all the pores which are available of different sizes, be it macropores, which are the big channels, the mesopores, slightly thin channels, and then comes the micropores, which are further thin, and ultramicropores, which are the smallest pores available. The hydrogen protons, when they are neutralized with electrons, they form stable atoms. The stable atom move in these pores and form the weak chemical bond on the surface, internal surface of the pores. So we definitely need more pores and more surface area. That's why we use the activated carbon, not only carbon. I hope I answered your question.
Yes, sir, but I want to know how to activate carbon chemically or physically.
Oh, you just Google it out. See, physically, it has to go through a series of process by passing on the steam and the gases. Okay, by steam reforming, and nitrogen gas and CO2 gas are passed to activate it. That's a physical form in a tube furnace. And chemical form, normally KOH, potassium hydroxide, is used. And there are other chemicals used which are treated, the carbon is treated in an inert atmosphere with these chemicals to convert it into activated carbons at a designated temperatures.
Okay, sir. Thank you so much, sir.
My pleasure. Other queries, guys?
Yes, sir. Good morning. I'm Dr. Raghavendra Upadhyay.
Very good morning, Raghavendra ji.
My knowledge about these things is so very superficial, but I'm not able to understand how the electrical vehicle and hydrogen technology are related to each other, and whether hydrogen technology can provide us 100% solution or not. If it can provide the 100% solution, then why are we going for so much infrastructure for the EV?
Very good question and very valid question, Raghavendra ji. Now, it's all about the round the trip efficiency. When I say round the trip efficiency, who is taking the round the trip? The electricity itself is taking the round the trip. We are charging our batteries, we are feeding in the electricity, and then we are taking out the electricity to power the drivetrains. Similarly, in the hydrogen, when hydrogen is used as an energy carrier, we are feeding in the electricity to produce the hydrogen first. Then we are storing the hydrogen, and then we are taking out and consuming the hydrogen to generate the electricity back. So electricity in to electricity out is the round the trip efficiency of the electricity. The answer to your question is EVs solely are not the sustainable solution. They could be the green solution. Similarly, hydrogen fuel cell vehicles are not the only solution. It could be the green solution. The combination of two, combination of hydrogen fuel cell and the battery based hydrogen fuel cell, that's why it's called EV hybrid or the fuel cell hybrid. The vehicle which is have the fuel cell as well as the battery, that is the sustainable solution that will provide you not only the longer range as compared to the EVs, but also the sustainable solution, because the output is zero and you are not polluting anything. And in batteries, we definitely are looking for these proton batteries to be commercialized sooner or later, because the gravimetrical energy density that we are achieving is still very low as compared to the set targets. Once we improvise on the gravimetrical energy storage densities, we are sure that we'll be able to commercialize the proton batteries, which are capable of replacing the lithium-based batteries. Okay, because these hydrogen batteries, they are non-self-discharging. The hydrogen will retain in the porous carbon electrode until unless it is used. Even after 1 year, you can use this battery and you will see the charge is full. It's not self-discharged. Okay, Raghavendraji, the solution is the combination as far as today's world is concerned. Okay, today's top world is concerned. Yep. Sole EVs will not be able to solve the problem, and sole fuel cell will not be able to solve the problem alone.
Sir, can if you have some kind of the data, just discussion, how much efficiency difference between solely electrical vehicle and this hybrid with hydrogen? And
the hybrid with hydrogen, full tank of hydrogen will provide you 700 miles, 700 kilometers of range, and electrical vehicle only around 480.
Just one more question. If I'm having this hybrid technology vehicle, means we need not to bother about the distance we are traveling, as in the case of solely electrical charged vehicle.
Conditions apply. Conditions apply means you need to have a dedicated infrastructure to charge up the vehicle with the hydrogen again. If not, you need to have a domestically charging station in your car. Now imagine the car of the future. The rooftop of the car is powered by solar PVs, the flexible third generation solar PVs, and the electricity that is being generated by the PVs is running your electrolyzer or the URFC, which is you just need to feed in the water, and water is disassociated within the car, and the produced hydrogen is stored in the tank which is in your car, and that tank is supplying the hydrogen to your fuel cell, and fuel cell is driving the drivetrains. Okay, then you can produce the electricity domestically on site at the car on board.
Me actually, as a learner, or as a teacher, even as an entrepreneur or as a service provider, it seems everything. But when I am seeking all this scenario as a customer, so it is very confusing scenario. Means I am unable to decide. But so why it is so, sir?
Raghavendraji, I tell you why the confusion is there, because so far we are still relying the best possible from consumer point of view. You just not have to see the consumer point of view, what are the things available. You also have to see the after sale services. Who is going to provide you the battery? Who is going to charge your battery? I mean, where we belong to, we are somewhere here in Punjab, in the northern part of Punjab. Here the electricity cost, the domestic electricity cost is 9 rupees 25 paisa. So instead of charging my battery with such a high cost electricity, I'll prefer either charging my fuel cell with hydrogen or producing my own electricity and generate my own hydrogen. Okay, so from consumer point of view, you also have to see the market and the after sale service which are available. Say if you are buying the hydrogen fuel cell vehicle and no hydrogen refilling station is there in the country, it's of no use. It's still on the research desk. The policymakers have to make the decision whether they want to promote the hydrogen fuel cell vehicle or not. I hope I answered.
Hello, sir. Hello, sir.
Yep.
Yes, sir. This is Digvijay.
Hi, Digvijay.
Yes, sir. So there was one point in your presentation about emissions.
Yep.
Yeah. So in conventional IC engines, we have NOx and SOx emissions, and they have some heat carry with them. So that is the reason behind this global warming at one point. And then you said that fuel cell hybrid vehicles, water vapor is the emission out of it. And but I doubt that water vapor will also contain some heat. And again, that global warming aspect will come in picture.
Good question. Let me answer you. Now, if you compare the heat being produced in the fuel cell and heat being produced in the IC engine, there's a huge difference. The temperatures, the inside cylinder temperatures of the IC engine can range from 1500 degrees Celsius to 2500 degrees Celsius, depending upon the size of the IC engine and the fuel you are burning in. But fuel cell, we are not dealing with such high temperatures. No, the heat emitted from the fuel cell, it's only around 80 degrees or 100 degrees, not more than that. It's not going to cause any harm.
Okay.
Okay, it's not going to produce the exhaust gases which have got such a high temperature. That's why, most of the research is going on in IC engines exhaust is that they are trying to recover the heat which is liberated out from the... If the exhaust is too hot, you want to regain that heat using either the thermoelectric generators or any other source.
Yes, sir. Thank you, sir.
Okay. Any other query?
No, sir. Actually, your presentation is very nice, and all the things you have covered very beautifully and thoroughly.
Appreciate that, sir. Thank you so much, Raghavendra ji.
Thank you, sir. But still, I am asking this question to many people, but no one is answering me. That in all the presentation, I am seeing that everybody is claiming that EV is going to kill the pollution kind of the things. But still, I am not able to understand if I follow the law of conservation of energy.
Very good, very good.
Then ultimately, electricity is going to come from the burning of the coal.
Correct. Exactly my point.
Coal will burn, how this is justified?
Exactly my point. Exactly my point.
Just
not all.
One more question. Also, I want to add. I asked this in other platform also, but I was not satisfied with the answer.
Please ask.
I'm feeling you are the eminent person, and you will answer me.
I'm glad.
In 93, 94, when my father purchased a two-wheeler and I filled my tank, the cost of petrol was 16 rupees per liter.
Yep.
And now it is 116 rupees per liter.
Okay.
So how anyone can give us the guarantee if the volume of EV will increase, the cost of electricity is not going to increase?
Is that it?
Yes.
So two questions. Let me answer you
Yes.
clearly.
Yes.
Let me take this. Okay, there's another question by Urmila. Okay, Urmila, I'll answer you. Let me answer Digvijay first. Not Digvijay, Raghavendra ji first. Raghavendra ji, see, in one of my slides, I said not all the pretty things are pretty. I mean, not all the green technologies are sustainable and not all the sustainable technologies are green. EVs or the battery-based EVs, they are projected as green technology, but not the sustainable technology. Okay, if you talk about the net zero carbon footprint, that's not what battery is made up of. Lithium, what you will do when the life cycle is over? Okay, that is why we have come up with this proton battery, which could be the replacement to the lithium bait. It's not ready to be commercialized as yet. We are not using any lithium in this battery. Battery, what it does, it stores the charge. The proton battery, which I am working on, what it does, it stores the charge. Over there, the charge is stored chemically in form of either the lithium-based ions or other ions which are available in the electrolyte. Over here, the charge is being stored solely in the form of hydrogen ions, H+ ions. Okay, so the answer to your first question is, I completely agree with you. EVs or battery-based solution, they are the green solutions, but not the sustainable solutions. Okay. And there is no guarantee that their cost is going to go down. As far as the electricity production is concerned, I'm very sorry to say, for our energy needs, for most of our energy needs, we are still relying on the fossil fuels. The electricity that you and me are using, they are coming by burning the coal. They're not coming from the renewable. It's only in the hand of the decision makers or the policy maker of the country, whether they are switching on, how fast they are switching on to the renewables for the energy production and meeting the energy demand of the country. Your second question. Sorry, I forgot what it was. Raghavendra ji, can you repeat?
Yeah, actually, that is related to cost of the electricity, because since today we are not having so much volume of EVs, so electricity cost is low. But even in few presentation, I am seeking, I have seen a huge investment on the charging and all that. So once this investment will come into the market, what is the guarantee that tariff will be cheap for the customers or for the consumers?
The only solution I foresee is producing your own electricity domestically using the renewable source like solar PVs or wind, whichever source is available across Europe. And then storing the excess electricity during the peak hours in the form of hydrogen. Or you can charge your batteries of the EVs. That's what I foresee.
But on this basis, can we move for EV? Because Solar is not always a good solution.
Again, if we really want to bring down the cost of the EVs, the government have to intervene. The charging station need to be subsidized. And nowadays, the new term has been emerging in the research world, that is the land used per unit production of the electricity. Okay, in that particular term, solar PV lags far behind, far behind. So the solution could be either the government come forward to provide the subsidies and set up the charging station, not only just based upon the PVs, the photovoltaics, but based upon the other source of renewable energy as well. Let me tell you, there are many renewable sources of energy as far as India is concerned, which are underused. Geothermal capabilities are immense in India, but I do not see any commercial geothermal power station which is running in India or even being installed in India. Okay, so the policymaker have to come forward. Just projecting the battery-based EVs as the green technology and the solution for tomorrow won't do. It's not the sustainable solution at all. The electricity cost has to be reduced by switching on to all the form of renewables, not only one form of renewable. The things have started changing. I mean, the solar PV, the cost of solar PV used to be quite massive. Now it has reduced significantly so that it's affordable by the common people. So similarly is with the batteries and similarly is with the EVs. I hope I answered your question, Raghavendra.
Yes, sir. Yes, sir. Thank you very much. And you answered in very clear words. So I'm also grateful to you.
My pleasure. My pleasure.
Yes, sir. Yes, sir. Yes. Thank you. Thank you very much.
My pleasure. I'm open to take other queries. Please do not hesitate to ask. I could be reached on my email IDs as well. There was another query in the chat box. Let me take that. Urmila, sir, if normal car, if temperature increased, we can use coolant in EVs. For temperature increase condition, what is the provision provided in EVs? Okay, in EVs, see, the temperature are not as high as in IC engines, Urmila. Battery maximum temperature could reach around, say, 200, not more than that. So that can easily be cooled down by air cooling, by air draft, which is, if the vehicle is moving, there is a hell of an air draft which is available for the cooling purpose. So that can be used. Another thing, if you want to increase the efficiency of the cooling of the battery or the EV system, you can definitely go for the heat sinks, the heat pipe technology, introducing the fins on the battery, and some electronic cooling gadgets. Okay. Dr. Ram Singh, hello. What is the scope of two-wheeler EVs in Punjab? Sir, there are many two-wheeler companies, like Hero is one, who have launched their two-wheelers in Punjab. But the only sorry situation in Punjab is the domestic electricity cost is too high. It's 9.25 paisa per unit, domestic electricity, and commercial is even higher. Okay, and there is only very less provision that is being made for battery swapping or for battery charging on the commercial grounds. There are no subsidized government charging station available for this battery. The person who is buying the two-wheeler, EV two-wheeler in Punjab is bound to charge that two-wheeler at their home. Okay, and the cost is too high. So the scope I foresee is only limited until the government jumps in and reduces the cost of the electricity, or some entrepreneur set up the charging station which could be powered by either solar photovoltaic or some other source, and that can provide the charging of the battery at subsidized cost. Okay, but unless these solutions are being made, the EVs are not going to sustain for long, the two-wheelers especially in Punjab. Okay, what about the service and repair of these two-wheelers in EV? See, servicing in two-wheelers generally does not contain a long propeller shaft or the engines which need to be serviced. The mechanical parts are quite less in EVs, which can be easily serviced by any shop vendor which is close by. But if a technical winding, rewinding of the drive motor is required, a dedicated electrician need to jump in. Electronic circuit cannot be repaired over here by a shop vendor, sir. It has to be repaired in the company from where you are purchasing the EVs. Any other queries, please?
So share your details, contact details.
Sure, I'll do that. Ruchika ma'am, are you there?
Yes, sir. Yes.
Ma'am, the quiz has to be asked by myself, or there's going to be a centralized quiz? Because
no,
I've
there
put down.
will be a centralized quiz in the last session of the day
Okay,
at 3
fair
p.m.
enough.
Sir.
So I'll skip that.
Yes, sir.
I'll skip that. So these are the takeaway from today's session, guys. You should be absolutely clear in your mind that there is a distinct difference between the green technology and the sustainable technology. Again, I repeat, not all the green technologies are sustainable. Okay, and not all the sustainable technologies are green. Okay, and lithium-based batteries cannot meet the global energy demand because lithium is not available in abundant on this planet. The global energy demand is immense. It cannot be fulfilled just by lithium. And recently you might have heard about Afghanistan. They have got the biggest lithium resource and which is being captured by the Taliban. And I'm sure the lithium-based batteries are going to shoot up in the prices quite soon. Now the future vehicles would not just be EVs, but a hybrid of the EVs as well as the fuel cell vehicles. So EFCVs. Efforts must be made towards making the surroundings carbon neutral, and all must try, we all, you and me, we all must try to contribute towards development of a sustainable society. So thank you all. Questions I've already taken. My email ID is displayed on your screen. If there is still any query, I could be reached on this email ID. Padmavati, hydrogen cell will never explode as far as Toyota, they shoot the 0.5 caliber of the round in the fuel cell tank, in the hydrogen tank. The hydrogen being the lightest gas, it simply disappeared in the air, but it never exploded. To explode the hydrogen, you need a spark to be produced and some other source of flame. So they never explode if you are using it in the fuel cell. But if you still think the gaseous form of hydrogen is storage, go for the electrochemical storage of hydrogen, which I'm currently working on. Yes, okay, Padmavati?
Yes, sir. Thank you, sir.
Any last query from your end, guys? Well, to clarify your doubt, the picture which is showcased on your screen, this is the end plate of the fuel cell which is being machined in my hand. It is yet to be machined. There are no flow channels, but only the depression have been cut of the end plate of the proton battery.
No other questions?
I don't think there is any, ma'am.
Thank you so much, sir. I thank Dr. Amandeep Singh Oberoi to spare his valuable time and be the part of our FTP. I thank you so much, sir.
My pleasure, ma'am. It was a pleasure interacting with such a beautiful audience. Thank you for being a patient.
Thank you all. Guys. We'll meet again at 11:30. So we'll be having with us Dr. Yaduvir Singh in the next session. Thank you, sir.
Thank you, ma'am. Thanks a lot. Thank you all.